Okay, you have a homework to do, but since some of the questions might be slightly different or have some techniques that you will have to learn, I would like to do this homework once first. However, you will still have your chances to practice because I have deliberately changed the numerical values of the numbers. So your homework, the real one, will have different numbers. So don't worry. Question 4 to question 6 you still do by yourself with very similar techniques and things to know. Okay, so let's start with the equations that we have already learned. For example, here energy is equals to power times time. Okay, another way to write this same question is P equals to E over T. Power equals to energy divided by the time needed to deliver. Okay, this is the first important equation. And the second one is what we have just covered, is that Q and E is they both are referring to the heat energy. Just E is more common, but Q is very specific for heat energy. Okay, let it be. And here M is mass, C is specific heat capacity, and delta T is the change in temperature. So you might be slightly confused by now because there are so many symbols, so many different things they are referring to. So let's have a quick revision, and this part is the same as your homework. So if you can follow and understand this, or if you skip it and just copy them down, you will still get the marks, but these are important concepts for you, so you better learn. Okay, physical quantity. For example, energy is what we mean by capital letter E, and the unit for energy, of course, it is joule. Okay, for the complete name is Joule, but you just write J, it's okay. And I will speed up from now on. Power is P stand for power. It means how fast you deliver the energy, and the unit is watt. W-A-T-T, and the symbol is watt. What does it mean? It is joule per second, or you can write joule per second. It doesn't matter. Okay. However, only this part is enough for the homework, I guess. And T and T, this is different. Small letter T stand for time. Big letter T stand for temperature. Don't ask me why. This is in fact the convention, the 传统. Okay, so the unit, the standard unit for time is second. Yes. And the unit for temperature is degree Celsius. And then M stand for mass. It means how heavy, or how what is the amount you have, and the standard value, standard unit is kg. C, the specific heat capacity. This unit is the most complicated, just like the name. The name is most complicated among this table. It measures how many energy is needed per kilogram per degree Celsius. Okay, if you have 1 kilogram of that material and you want it to increase by 1 degree Celsius, it will take that number of joule of energy. That is how we measure specific heat capacity. Okay, I know this specific heat capacity is quite a new concept to you, but that is physics, what we have to learn in Form 3. Okay, specific heat capacity, how difficult it is to heat up something. Okay, or how many energy is stored when a degree Celsius of temperature is increased. Okay, so question 2, the truth of an object depends on its material but not volume and mass. Here you can simply duplicate and put it here. Okay, this is the specific heat capacity of an object. It only depends on what type of material it is. If it is water, then no matter you have a huge bottle or just a small bottle, the specific heat capacity of that is still the same. As long as it is water, then it is 4200. Okay, only material, but not affected by volume and mass. And then specific heat capacity is how difficult it is to change the temperature, right? And then, so for question 3, when we compare two objects with the same power, so the energy provided is at the same rate, then compare the temperature change of the object. So here it is smaller or larger. Does the object with a smaller or larger specific heat capacity will increase the temperature at a higher rate? So it is here increase at a higher rate, so it is easier to heat up. So if specific capacity measure how difficult it is, then easier will mean a smaller value. Okay, smaller specific heat capacity. Okay, finished the concept clearing part, and let's begin with the calculating section. Okay, I hope this video won't be too long. Let me prepare my calculator first. Okay, read the question first. What does the question after? Find the energy consumed by the heater and find the specific heat capacity of the liquid. And now we have a look what information is being given. Okay, we have 1 kilogram of liquid in a beaker heated by a 1000 watt heater. Okay, the temperature is increased by 17 degrees Celsius after heating for 3 minutes. Suppose all energy consumed is converted. That means no energy loss to the surrounding. Okay, in the example 4, we know that when there is energy loss, then the calculation is not that accurate. Okay, so here when the question tells us assume there is all the energy is converted, that means no loss. Okay, so find energy consumed by the heater. Okay, when we talk about heater, then first thing first, we will immediately think of the power of the heater. And since we have already learned two equations, which is E 等于 PT and EQ 等于 MC delta T. Okay, here when we use the heater, energy equals power times time. And what is the energy here? It is power. Here it is 1000 watts times 3 minutes. That is how many seconds? 3乘60就180. That number of seconds in the process, you need not write the unit. It is okay if you did, but without is also alright. 1000乘3乘60就會計到呢個啦，等於180,000 joule. Okay, that is part A. And then part B, find the specific heat capacity of the liquid. So when we want to find the specific heat capacity, we use the equation with small letter c. Okay, so Q 等於 MC delta T, and then one by one, the energy from the heater is used to heat up the liquid. So by logic, this value is then plugged in here. And then what is the mass? Mass is 1 kilogram. And then what is the C? C is what we are after, so this is the variable we want to calculate. And then what is delta T? Delta T is change in temperature, and since it says increase by 17 degrees Celsius, so delta T is 17. This is 1. Okay. Then let me get back my red pen. 咁咧，我哋代落去180,000咧，就等於1 kilogram times our variable times 17. So C is equals to 180,000除17，就會等於180,000除17，就係10588 Joule per kilogram per degree Celsius 啦。The answer seems too big to be real. Maybe it is because the number is too big because I changed the numerical values randomly, and maybe that is what results in a seemingly unreasonable answer. But that is how we do this kind of questions, okay? It's too big. Almost 3 times that of water. Okay, let it be. Okay, question 5. Alex measured the specific heat capacity of a metal. Then the process, he heats a piece of 1.2 kilogram by a heater with power 1500 for 1 minute. Suppose all energy consumed, so no energy loss. Assume. And now is find the energy consumed by the heater. Okay, find the energy. So both equation is possible, but all we know about the heater is this 1,500 and 1 minute. Okay, so the energy here we use Q equals to power 乘 time. Then this is 1500乘60 second. Therefore 90000 Joule. Then if the temperature increase from 20 to 85, find the specific heat capacity, that is C. So part B, Q equals to mc delta T, and making subject of C, we have Q over m delta T 飛佢過去 okay, and Q we have calculated 90000 Joule. Mass is here 1.2 kg. Delta T is from 20 to 85, so actually 65. And then we calculate this 90000除開括弧 1.2 乘開括弧85減20，直接撳65就得啦。And then the specific capacity is 1150 1153.8嘅其實，但好多時我哋計3個式域啦，3個有效數字1、2、3，咁所以之後就45入啦。Joule per kilogram per degree Celsius, and then I have to write 3 significant figure. Okay, that is question 5. Very simple. And then question 6. David used a heater with power of 1600 W. and then heat up temperature 21 度 at the beginning, and then the mass of the water is 0.5 kg, but this time it does not say no energy loss. On the contrary, it says if 65% of heat is lost to the surrounding. Find the temperature of the water after 3 minutes. Okay, so this time we have an energy. However, after transferring the energy from the heater to the water and the lost, actually most of the energy is lost, 65%. That means only 35% is really given to the water. This is lost. Okay. You can also draw this type of diagram for your own reference, but the marking will not count that. Okay. Whatever. Let's start the calculation. So let's calculate this part before the loss. How much energy are there? Okay, first energy, heat energy equals to power times T, PT, and the power here before the loss is 1600，寫到好似1660咁，1600乘3乘60咁多秒嗱。Remember to convert to seconds every time because power W is joule per second, so you have to convert it to second to calculate the correct answer. 1600乘3乘60等於288000等於288000 and this is joule, and then this is the energy provided by the heater. However, the water did not receive all of them. Energy receive by water is less 等於1減65% 乘以28800就會等於0.35乘28800 enter 100800 joule. Okay, that is how much energy the water truly gets. And then in order to calculate the final temperature, we have to make use of the equation Q 等於 because heating up, so we will have to use mc delta T. However, what we are after is the final temperature because the initial temperature is 21 degrees Celsius. This is already given. So let me slightly change the formula because this is temperature final minus temperature initial, right? And then what we want to calculate is actually this part only, and other things we can plug in. So Q 除 MC 就會等於 TF 減 TI 啦，將呢邊飛過嚟啦，然之後呢，我哋就再將 TI 飛過嚟係減變加，呢個飛過去就加變減，唔係喎，我要做咩啊？哦，我知啦，拉過啲先。TF is what we are after, so this part come and become plus, and then swap. Okay, that is the final form. And then here 100,800 plug into Q. Mass is 0.5 kg. C is 4200. Temperature initial is 21 度. Therefore, we have 100,800除 0.5 乘4200再唔係乘啊呢個，再加21度。This is equal to 69 degrees Celsius. Whew. Okay. Key point of this question is to learn how to deal with the energy loss according to the question. Okay. If you plug in this, then you will calculate another value. And also the techniques of changing subject is also very important for physics or mathematics in general. That is it. So I have demonstrated how to do the assignment and hope you can do well in your version. Bye bye.